back. Again, I hope we don't have these video issues. If not, I'm going to have to sort of check into maybe changing what I do. Okay, but we're going to be talking about stateful transformations. So this is Patsy again. This is going to be a really short one. This is sort of an admonition, a warning video. Okay, so you are doing Patsy. You want to go ahead and you want to center your data. So you make a function called naive center, which is it's like naive, if you name it naive center, you probably know what's up. But you make a function called naive center. Please don't use this. You go ahead and you take your data. And you feed it into a design matrix, and it looks centered. You think, wow, I've done a great job. And you go ahead, you train your model, and you get some testing data, and you feed this testing data into your matrix in order to transform it right before you're about to do model fitting, and you look at it, and you're stunned. What's wrong? It looks like it's centered. But this is not actually centered. What this was is you got a doctor's report saying that this person had 1, 2, 3, 4. So we had one person with 1, one person with 2, one person with 3 infections, right? You want to center them. And you get some testing data with someone that has 5, 6, 7, and 8 infections, like really bad, right? This data looks exactly the same as this. That doesn't make any sense. The problem here is that it's taking any data set that you give it and it's recentering that data set. And that's not what you want. Instead, during train time, when you're training your model, you want to figure out what the center of that training data is. You want to use that approximately for the center of the test distribution. Anytime you get a test piece of data, you recenter it, and then you run your machine learning model on it. This is a really common trick or trip up that can happen, and Patsy has made it really easy for you not to do this by including a function called center. Okay, and center does this exactly the way it should. So center, we did it on the test data. On the train data, on the test data, look, it's much higher, as it should be. Okay. This can also be a problem if you're working with large data sets. So we go ahead and we use our naive center on a large data set using the ink builder. I'm not going to be talking about that a lot, but you can. Let's say you got this massive data set, you're doing big data, and you're really excited about it, and you want to use Patsy in order to do statistical transformations on that data. You can do it using ink builder. So whatever, you do this, you go ahead and you look at it and it's like, oh, it's all centered. If you use the actual center instead of naive center, you'll get results that are actually different. So these guys were bigger than the ones up here, versus up here they look all the same. Okay, so that's lovely. Info new data, what did I want to do with this? Yeah, and if you add new data, it goes ahead and automatically centers it. Okay, you can make new stateful transformation objects yourself. The stateful transformation object is super simple. I'll include it in the code that's linked always at the bottom of the video, so check it out if you're curious. In addition, you can go ahead and you can use the built-in one called standardize that does everything that you can think of that's useful. Standardize will take an X value. It will center it if you want. It will rescale it if you want, meaning it will divide by the standard deviation. And you can even choose which type of standard deviation, whether it's going to be population or it's going to be the sample standard deviation by specifying the degrees of freedom right here. Okay, I hope this is somewhat useful. I don't know if you've ever run into this problem before, but I'll keep this short. Please tune in. Next time we're doing splines, which are literally the most fun that you can ever have doing statistical transformations on data. So I buckle in and let's get ready. Thanks.